This video is a Unit 2 overview on graphing linear equations and inequalities. It says here students graph linear functions and show their intercepts. Students graph the solutions to a linear inequality in two variables. So the following are a few samples of what you'll need to be able to do in order to be a proficient student on this unit. Sample task number 1 says, show the remaining representations below and explain any connections you notice between the two representations. So you can represent an equation not only by an equation but by a table, by a context like a real life situation, and by a graph. So in this situation we are given the table. So one method of graphing is by using a table of values, and we can write that as one of our first key ideas. Okay, and so in order to do that you have to know how to plot points on a coordinate plane. So in this table we have days and we have the cost. Okay, so the days are your x value and the cost are your y value. So your first coordinate is 1, 2. So I will go to the graph and I will go over 1 for x and up 2 for y. And then our second coordinate is 2, 4. So you go over 2, up 1, 2, 3, 4, plot a point. The next the next coordinate is 3, 6. So I go over 3, up 1, 2, 3, 4, 5, 6. The last one's going to be a little bit off the charts, but I can visualize where it is. 1, 2, 3, 4, 5, 6, 7, 8. So about here. Okay? So I want you to notice that when I do this, I am not going to go beyond the origin. The reason why is because when you go beyond here in the x-axis, you're into negative numbers. And there's no such thing as negative days. There's such thing as no days in regards to a cost. If it's $2 per one day, no days would be $0. So 0, 0 is okay. Okay? So now, looking at this, if I look at the graph here, I can identify the y-intercept, which is 0, 0. Okay, that's the y-intercept. And I can identify the slope. The slope is the rise over the run. So we're going to rise 2, go run 1, rise 2, run 1, rise 2, run 1. So the slope of this line is 2 over 1. Okay? Now I want you to notice something here. For each day, the cost increases by 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So you'll notice that a linear equation has a constant rate of change. So let's go ahead and write that, constant rate of change. And the rate of change is the same as the slope, as you can see. Plus 2, plus 2, plus 2, up 2, up 2, up 2. Okay? So, once we have the slope and the y-intercept, we can write an equation in slope-intercept form, y equals mx plus b. We're going to replace the m with the slope of 2 and the plus b with the y-intercept of 0. And there we have our equation. Y equals 2x plus 0. And you don't have to write the 0, you could just put y equals 2x, it's the same thing. So in thinking about context, I think, well, what's something that could possibly cost $2 a day? It's kind of expensive, but a movie rental came to mind. So my context for this is you rent a movie for $2 per day. Okay, and then you could even go as far as making a question, like how much will you spend if you keep the movie for 4 days? You probably can come up with a bunch of different contexts. Okay, so here we talked about slope, rate of change, slope-intercept form, we talked about, let's see, real world situations, and intercepts. Okay, so in sample task number 2, it says to graph the following equation and then state whether or not the given point is a solution to the equation. So speaking of intercepts, for number 2, we're going to graph this in another method. We're going to calculate the intercepts. Okay, and we're going to use those intercepts to graph using intercepts. Okay, so we could rewrite this equation in slope-intercept form, but in order to show you all 3 methods, we're going to go ahead and calculate the intercepts. Now this is our y-axis and this is our x-axis, okay? So if a point is on the y-axis, you'll notice if it lands on the y-axis, the value of x is 0. So what we can do to find the point that lands on the y-axis is we can substitute 0 for x. So here we would have 1 times 0 plus y equals 4. 1 times 0 is 0, so you get y equals 4. So the y-intercept here is 0, comma 4. Notice the x was 0 that we plugged in, and the y is 4. So we can go ahead and plot that 1, 2, 3, 4 right here. Okay, and then if you'll notice, if you land on the x-axis, your value of y is 0. Therefore, we can take the same equation and plug in 0 for y and solve, and we get 1x equals 4. Divide by 1, divide by 1, x equals 4. So the x-intercept is 4, comma 0. The x is 4, the y is 0. Now be careful. You'll notice it's very similar here, and kids often mix them up. Make sure you list the x first in the ordered pair and the y second. So this one would be 1, 2, 3, 4. Plot your point. Now we just take a straight edge, and I'm just going to be using my Lego piece here, and you're going to connect the 2 points, creating your line. Okay, so we're not done here. You're going to notice it said graph the following equation, which we just did, and state whether or not the given point is a solution. So the given point here is 1, comma 3. So I'm going to go ahead and just plot that here, 1, comma 3. And you'll notice that it lands on the line, which means yes, 1, comma 3 is a solution to this linear equation. Okay? All right. Now we're going to move on to our last sample task, which says graph the inequality, then pick a point and use it to determine which half plane should be shaded, then shade the correct half plane. All right. So the first thing we need to do in order to graph this inequality is to write it in slope-intercept form. So we'll go ahead and write that again. This is what we use when graphing inequalities. So we're going to subtract 5x from both sides, and we get negative 2y is greater than or equal to negative 5x plus 10. Divide everything by negative 2. And when you divide by a negative and you're dealing with inequalities, you have to flip the symbol. If you forget to do that, it will be wrong. Okay? So here we're going to identify our slope and our y-intercept. Okay? Our slope is 5/2. So we're going to go up 5, rise 5, and go forward 2 since it's positive. And then our y-intercept is 0, comma, negative 5. So we can go ahead and plot the y-intercept at 0, negative 5, and then we can follow slope to 2 more points. So we're going to rise just following these directions, up 1, 2, 3, 4, 5, forward 2, up 1, 2, 3, 4, 5, forward 2. Now, when you're graphing an inequality, you have to determine if you're going to shade up, if it's solid or dashed. So look here at the inequality. Because there's an equal to symbol, that means that the points on the line, since they could possibly be equal to, are part of the solution. So we're going to have a solid line in order to show that. Okay. Next it says pick a point. So I'm going to pick the point 1, 2. And I'm going to plug this into my equation to see if it makes a true statement. If it makes a true statement, then this point is part of a solution. If it makes a false statement, then it is not. So for y, I plug in 2 is less than or equal to 5/2 times x, which is 1, minus 5. And I simplify and I get 2 is less than or equal to 5/2 minus 5/1. I'm just writing the whole number as a fraction, and then I need to make common denominators in order to subtract. So now this is going to be 2 is less than or equal to 5/2 minus 10/2, and then you get 2 is less than or equal to negative 5/2. Is a positive number less than a negative number? No. So that means this point is not a solution, and therefore you are going to shade the other half plane. So on the other side. So all of these are solutions to the inequality. You will also notice here it says y is less than or equal to. So if you go to the y-intercept, y is less than going down, and you'll notice that's on this side. Okay? So you would be shading below. So here we have to determine solid or dashed, and we have to determine shade up or down. Okay?